All right, welcome to the Alaska TTAP webinar series. Today's presentation is by Michelle Wilber on electric vehicles in Alaska. So, Michelle, take it away.
Thanks so much, Victoria, and thanks everybody for being here. I see at least a couple friends in the participant list. My name is Michelle Wilber. I lead up the investigations or the team looking at beneficial electrification in Alaska for the Alaska Center for Energy and Power at UAF, although I am physically located in Anchorage, where it is raining mightily today. And so what that means is that we look into performance and applicability and equity considerations and everything else related to electric transportation and electric heating, mostly, although there are a few other technologies that might be of interest. And my personal research mostly has revolved around electric vehicles in Alaska for the last few years. My background is in engineering, but I work with a team of people, including some really great social scientists, economists, policy folks, and others at UAF and UAA, as well as some amazing community partners, including school districts, tribes, local EV experts and aficionados, electric utilities, cities, and others. And lately, we've been working most closely with the communities of Kotzebue and Galena. And so we also do collect data and do research on electric vehicles operating in other parts of the state as well. And some of that data will be shared in this presentation. Like I said, I'm an engineer. I love graphs. I love numbers. I love fitting lines or curves to things. If that's not your bent, I definitely look forward to trying to have conversations at the end to make sense of anything I've shared that didn't make a lot of sense to you. But a lot of this, I'm going to talk about kind of how we've gone about our research. And a lot of that has been to date as part of a National Science Foundation funded grant that was a planning project. And so that involved doing a lot of the legwork to figure out rural Alaskans are the experts on what they need from their vehicles and how vehicles work for them and what would be better or worse about other technologies. And so we did a lot of legwork going out to Kotzebue and Galena and also to Bethel. The researchers from the universities going out, the folks we were working with on the ground in those communities, of course, already being there, having public meetings and talking to a lot of interest holders and fleet owners and others in those communities about their vehicle needs and some of the potential or perceived barriers and benefits to electrification. So like I said, we had community workshops, and even though the three communities we were forming relationships with were of very different sizes, we generally got about 10 people at meetings, no matter the size of the community, which is amazing for a small community like Galena and much less of a percentage of the community in a place like Bethel, but still great people to interact with. We did some social science data gathering, not my field, but helped along by Jen Schmidt and Toby Schwarr, the social scientists on the team, where we did some sort of guided exercises. I apologize to people. I felt like I was kind of putting them back in the school setting where you had to bubble in your answers. But we were really trying to get at perceptions of barriers to electric vehicles in rural Alaska. We came with a pre-made list of some of the commonly pointed out potential barriers to electric vehicles, like what do you do with the battery at the end of its life? What about the cost of electricity to fuel it? What about the original purchase price of the vehicle? What about range considerations, things like that? We also asked people at the meetings what they saw as potential barriers and got a lot of things that make sense, but maybe aren't on the national picture. Things like weight, because you have to pay to barge your vehicles into communities. And if you're going to send them out for warranty work or repair work, which doesn't happen often, but does happen, that comes into consideration with those transportation costs in a big way. So So things like that. The roads are bad in many places in rural Alaska, worse than they are often in Anchorage or Fairbanks or on the road system. And so the fragility of vehicles, both in cold or in general, was also a concern because people saw that with other vehicles. When we went through the options we had provided in that structured, what's called a max diff exercise, these are the raw numbers. I think there's a slightly more statistically significant way to analyze that that's been done, but just in the raw responses to what people saw as barriers. The before and after is that we did do a presentation on what we know to date about cold weather considerations for operating electric vehicles in Alaska, both from anecdotal evidence of talking to people who are operating electric vehicles in Fairbanks and the North Slope and other places in Alaska, as well as doing a literature search about how vehicles are operating and using energy and possibly what money they cost the operator. We did that presentation, and that assuaged some people's fears, given that there's a lot of anecdotal evidence of vehicles operating just fine, electric vehicles performing at -40 Fahrenheit, losing a lot of range. But when those numbers were given to people, especially where road systems are limited, where daily driving might only be 4 to 6 miles for some vehicles, we saw that the fear of the vehicle not of breaking down, of cold weather performance, of range of travel, those barriers decreased in the responses. But something had to give because it's, you're ranking barriers, you're not giving them absolute numbers. And so concerns about the local ability to maintain the vehicle stayed high after a presentation on cold weather performance. Concerns about the price of the vehicle and the cost of electricity remained really high in people's minds, not surprisingly and quite logically. We also did a dot exercise. I kind of have some slides out of order. I've realized I have a picture of this exercise and I'll go into details, but we asked people if they were willing to use an electric vehicle for some of the ways that they're using vehicles in these communities. They weren't in all cases. Some of the vehicle use cases we had brainstormed, and I'll show you, were, for instance, marking trails with snow machines or doing search and rescue operations, and knowing the limitations of electric range on snow machines, as many people do who've looked into it, who are interested. And the needs for reliability and the uncertainty around new technologies. Those were not a vehicle people were really willing to swap out right now for an electric version, but for a four-wheeler or an SUV to run to the airport or take kids to school or go to work, those were use cases that a lot of our workshop participants were really interested, thought that they might try an electric vehicle for, all things considered. There was perhaps a lot of workshop bias in that people that came to our workshops were probably more interested and favorable towards electric vehicles than the general population. I will tell you that Facebook posts in all of these communities about electric vehicles often receive a lot of skepticism and outright negativity towards electric vehicles. So there's definitely a lot of range of public opinion out there about how excited people are to try out this new technology in their communities. We had been focusing a lot on barriers, so we also asked what potential benefits there might be. I don't think there's many surprises here either, but people pointed out a cleaner town, even though diesel power plants may still be burning fuel to provide energy for these vehicles. There are some efficiencies to doing that in a centralized way, and at least the emissions are not being released directly at your child's face height. So that was something people were interested in. There do tend to be lower maintenance costs, and depending on the relationship between electricity and gas prices and some other use factors, you can have lower fueling costs for an electric vehicle, even in remote and rural locations based on diesel power in rural Alaska. So some of those things, less noise, although less noise was sometimes brought up as a little bit of a potential barrier too, if people were worried about not hearing a car backing up because of the lack of engine noise, or running into a moose because it doesn't hear the snow machine coming. But I'll tell you, they do still make noise. So, there's perception and reality there maybe. We also went to the Chimay Dance Festival, and because we had a table there during one of our meetings instead of a room full of captive audience, we set up a information gathering experiment where we put some cups on the table with what had been pre-identified as the 3 biggest benefits and barriers, and just had everybody who came by the table, which was about 60 people, vote on what they thought the absolute biggest benefit and the absolute biggest barrier might be. And in that, for that region, the festival draws people from all over Alaska, but a lot of people from the YK region. Cost of electricity was big on people's minds as a barrier, and having cleaner air was the thing people thought might be the biggest benefit. So it's important stuff for us researchers to know what folks might be interested in seeing out of it, and what factors are maybe less important in transportation choices. This was, like I said, this is a little out of order. This explains better that use case and willingness to use an electric vehicle experiment. So we asked everybody in the room what vehicles they use for transportation, and of course all the things you would expect, like airplanes and boats and snow machines and Hondas or four-wheelers and trucks and cars, and all the choices came up. So they all got a sheet of paper, and then we asked people what they use vehicles for. And so, you can see some choices here. They were different in different communities slightly, but things like running errands, taking joyrides, taking trails, search and rescue, hauling freight back from the airport, going to another community upriver, all those sorts of things came up. We had some frequency of use, and we asked people to use 3 blue dots to label the 3 most used uses of vehicles. Sorry, that's a little redundant, but in their lives. And so 3 dots went on the boards for which vehicle, what use, and how often. And then we asked people to go back and place a red dot on any of their blue dots where they had no interest in trying an EV, bad use of an electric vehicle based on their knowledge, where they might be willing with a yellow dot, and where they were absolutely willing to try it out with a green dot. So all of that, although it seems like fairly anecdotal information, really helps us once we have some engineering data around energy use and price of electricity and characteristics of EVs versus gas vehicles, do some comparisons based on those use cases, and some intelligent mapping between what a use case is and how many miles that is, or et cetera, to get the idea of how much energy that use would take and what the cost differences and things would be. So very valuable information. Scientists, university researchers are really interested in how people use their vehicles in rural Alaska, and what that means for fuel use and costs and cost of living and all kinds of things. And there's apparently not a lot of really hard data on that. There are housing studies that look at energy use for heating buildings, and there's a lot of electricity data from the power plants, but less transportation data for a lot of rural Alaska. Back to some of the early stages of this research, before we started going to rural Alaska, those of us at ASAP that had been fielding inquiries about electric vehicle use in Alaska, since we study energy and power, people were turning to us with questions about how EVs might work in the winter and things like that. We put out a report. It's kind of long, it's kind of a dense read, but it is available on our website. That web address may be incorrect. If you have any problems finding it, you can email me, and my email will be at the end. But it's a literature review and some amount of anecdotal conversations with people operating electric vehicles in especially interior and northern regions in Alaska. And so it goes into the fact that while battery technology does not work particularly well in the cold, that is generally counteracted in vehicles with thermal management and systems to keep the battery happy and the occupants warm and happy. And so the upshot of that, usually the biggest thing is a range decrease. So if you are trying to get the full range, the 200 miles plus or whatever that modern EVs have in the middle of winter when it's 40 below zero, you will have to charge before you get to that range, because you're going to have decreases in how far you can travel on a full battery of half or more of the battery unavailable to you, because it's being used to heat the vehicle and keep the battery warm. So that is one true thing for people that have long drives every day. You can charge up when there are charging stations available. They come in different speeds. And the other thing is that to protect the battery that doesn't like to be charged or discharged when it's really cold, it can take longer to charge a cold battery. And the battery can be pre-warmed by the vehicle. There's various things around that. Happy to go into more details about how different vehicles are handling that to some extent. But mostly what I'm an expert on is having gathered energy use data for vehicles operating in very cold temperatures. So we've crowdsourced a bunch of data. A lot of the early adoptions in Alaska were Teslas. So we have a fairly large amount of Tesla data. And by that, I mean, a couple handfuls of vehicles. I don't mean hundreds. There are thousands of battery electric vehicles in the state right now, somewhere north of 3,000 least. But trying to collect the data and have it shared from people who are operating those vehicles, you always get a much smaller sample size, but it's telling a pretty consistent picture. So the x-axis in all of these plots is temperature, generally in Celsius, but -40 Celsius is the same as -40 Fahrenheit. 0 Celsius is freezing, so that's 32 Fahrenheit. Most of our data tops out just above 20 Celsius, which is room temperature. So we've plotted the efficiency of the electric vehicle, so how much electricity in kilowatt hours it takes per mile driven. There's a lot of variation in that because there's a lot of things that can affect that at the trip level. Was the trip mostly uphill, downhill? How fast did people go? How much wind resistance was there? How high did they have the heat settings on? Did they drive with a lead foot on the gas, or were they a really efficient driver? So a lot of things cause scatter, but we can see a general trend. So we have a bunch of Tesla data, mostly from Fairbanks, and we have data from a couple of Ford Lightnings that were being operated on the North Slope, and we are in the process of gathering more data. So if you know people that are driving vehicles in cold regions of electric vehicles in cold regions of Alaska, if they want to reach out to me, we will give them a couple gift cards to Fred Meyers for some couple years of their data. More details can be discussed. When we plot that versus the national data, the big takeaway from this plot, rather than trying to dive into all the things it shows, is that we're pretty in keeping with national data, that temperature and speed of the trip are two of the most important factors. Not the slower you go, there's a limit to that. But if you're taking your trips at 20 or 30 miles an hour, you're going to be a lot more efficient in an electric vehicle than going at highway speeds. And driving in cold temperatures increases your energy use because of all that heating. So those things are generally true. There is also energy used in electric vehicles when it's parked. Depending on the temperature it's parked at and how warm that vehicle is trying to keep itself, the inside of the cabin or the battery. And so if a vehicle's plugged in, the manufacturers will not tell me these details, but there are battery heaters, there are cabin heaters, and there are complex algorithms on how they manage those temperatures. Generally, when you're just parking your vehicle, it's not going to try to keep the inside of the vehicle warm unless you are preheating it for a trip, which you can do in a number of ways with different vehicles, either via an app or setting a departure time or just hitting a button on the key fob to get it to preheat. That's that really steep purple line on there that really uses a lot of energy per unit time. The colder it gets, that's if you're trying to keep the inside warm, or perhaps you're parked at the store or the post office and keeping it warm, but not moving. So that's not as much energy as to move the vehicle and make it go somewhere, but it is a fair amount of energy at cold temperatures. The other lower, not as deep sloped lines with a bunch of the red dots and blue dots and yellow dots at the bottom are different fits for vehicles that are just parked, just trying to keep the battery from being unhappy, keep it at a safe operating temperature. And there's different algorithms. Usually if cars are plugged in, they're using a bit more energy to keep the battery happy. If they're unplugged, they're still trying to make sure that battery doesn't get to dangerously low temperatures, but they're a little less aggressive on keeping it hot. And those things all have to be taken into consideration because they all add to your electric bill if you're an electric vehicle owner. So using this data and some other information about internal combustion engines, which is a gas or diesel vehicle, we've put together a model that is the back end of an Alaska electric vehicle calculator. You can get to it at that tinyurl.com/AKEVcalc that's on the screen. We worked with our partners in communities and the community members to help try to make this calculator as easy to use and insightful as possible. You only really need to put in 3 or 4 different things to get started. And if you want to really do a deep dive, you can choose to and put in more information like how long you're going to idle your vehicle and things like that. But to just get a quick overview, you can choose your community in Alaska from a drop down that pulls in some background database information on electricity prices and temperatures and things like that. You select the vehicle type between car and truck. Once we have real data on snow machines and four-wheelers and other vehicle types, we hope to implement that as well, but we don't have any real data right now, just assumptions. You put in the average number of days or miles you drive per day, how many dollars you pay for gas, unless the online database that we have access to has a recent dollar amount for your community, in which case that will pre-populate. If any of those numbers turn out to be wrong, you can adjust them and all kinds of other things. And then with just those pieces of information, but certainly if you want to adjust it, you can, you get an output that is the cost of an electric vehicle that you're looking at versus a gas vehicle, and also the comparison of the carbon emissions. This result is specifically for Anchorage and 30 miles of driving a day. The use case, how much you drive versus how long you're parked and what temperatures and whether you're in a garage or outside of a garage, all those things really matter. In this case, which is a fairly typical case for some people with longer commutes in the South Central Alaska area, you'll see that you're saving half the cost of fueling a gas vehicle and less than half of the carbon emissions. And then there's a breakdown by month and energy, where that energy use is coming from, whether it's from keeping the battery warm while you're parked. The little green bar here is assuming not much idling. This person isn't leaving it running during an FBI stakeout for 5 hours or something like that, just sort of typical idling while you're parked for a few minutes every day and driving. So that's different for different areas and communities based on temperatures, relative gas versus electricity costs and things like that, and use cases. So if you're in Kotzebue and you're really just kind of running to work and back a couple times a day or something, and you're not driving very much and you're using a truck, a standard truck versus a comparison new truck, so you can adjust the efficiency of your gas vehicle you're comparing it to as well, which is useful because we're comparing, say, the Ford Lightning electric truck efficiency to a new Ford Lightning, which gets an impressive 20 miles per gallon, but a lot of people's beater trucks in anywhere in Alaska don't get quite that good of fuel efficiency, so you can go in and adjust that. But with this kind of worst case for the EV comparison, if you are not able to use, and you can choose whether you are using PCE adjusted, power cost equalization adjusted residential electric rates, or full electric rates for businesses, or once you're past the PCE limits. But if you're not able to use PCE adjustments, an EV in this case, in this community, for this use case, would cost a little bit more than the gas version of the vehicle. You can see in the plot down below that that's mostly because of the high parked energy use for parking outside in the cold and trying to keep that battery happy. And the greenhouse gas emissions would be quite a bit more because Kotzebue is still adding wind and solar to their grid, and they're still not getting much more than 30%. If that of their energy from clean sources. So the cleaner the grid is, the better the deal. But a full diesel grid, or one with just a little bit of renewables at this point, there's a fair amount of emissions from that EV in really cold temperatures with certain use cases. The truth of the matter, though, is that it's very variable, and it doesn't take much to have it be cost effective or have the carbon emissions be in the right direction as well. This is a very complicated plot, so I am sorry to be showing this in general, but I'll try to explain it well enough for it to be understandable. So this is based on a whole bunch of modeling of real use cases that people told us about in rural Alaska. There are a whole bunch of dots under every kind of length of miles driven per day. That's because we're looking at different communities, different vehicle types, different idling times, different amounts they would plug in a block heater on the gas vehicle, all kinds of differences here. But there's a range of things. A zero line on this y-axis is break-even costs. The gas vehicle we're comparing to the electric version is the same cost to fuel, not for purchase. We're not looking at purchase costs. That's changing with time, but same cost to fuel as the gas version. Anything less than this means that the electric version is more expensive to fuel over the year. Anything above the zero line is it's less expensive to fuel over the year, and it's saving people money. Much rural daily driving is below 10 or so miles per day, and that puts you in a range where there's a lot of use cases that have a non-beneficial cost comparison to the non-electric vehicle. But that does depend on whether you're able to use those power cost equalization PCE rates to do at least some of your charging. If you have some room every month at the top of your electric bill before you get to the 750 kilowatt hours a month, and you can do some cheaper charging, that'll bump you up here. If you drive more per day, then you're spending more time driving where it's more efficient and less time with the parked energy use to keep the battery warm that kind of dings you. And so for cab drivers in Bethel that often are driving more than 100 miles a day on their car, or sharing with another cab driver and doing 2 shifts and doing lots of driving, that gets you way more into the cost effective if you're a fleet driver and you're getting more miles on that vehicle. And then certain vehicle types. We have anecdotal internet data on electric ATV use, and so we need to collect this real data to make sure that this is true. But it looks like an electric ATV that is not heating a cabin. So the Polaris side-by-side does heat a cabin, and that might ding it quite a bit, but there's no cabin heating here. And so they are way more efficient. And it looks like that might always be a beneficial switch as long as they're well made for winter weather. Snow machines are a bit of a mixed bag. First of all, they don't have a high range. So if you were going more than 40 miles a day, you would have to charge in between. And the other issue with snow machines is they're parked half the year, and the summer is the more efficient time to use them. So if you're using a vehicle in the summer, you're just getting that less efficient winter driving. So again, we're not completely sure of this data. We need to collect data and really adjust our model, but early results look like ATVs would be maybe the most beneficial vehicle. We've also looked at some heavy equipment, most of it in the Anchorage area. The municipality of Anchorage has an electric box truck and just got 2 electric garbage trucks. And it looks like those will be cost efficient fueling wise. Luckily, they got a grant because these heavy duty vehicles like buses and trucks and things tend to be 3 times the cost if they're electric versus gas. So most people deploying those are using Department of Energy grants or some other grant to help fund that. But as far as the fueling in South Central Alaska with the cheaper electricity on the rail belt, that is looking like a good deal as far as operations comes. Tok has an electric school bus that they got with some grant money. It is operating well for them, and they're doing it efficiently, and it drives at -40 Fahrenheit, no problem. They park it inside, so it doesn't have a lot of the parked energy use. But the problem is that Tok is on the road system, so they have reasonably cheap fuel, but it is on a diesel microgrid, so they have really, really expensive electricity. And they put in a solar array, but in the winter when they're driving that at -40, they're on 60 cent or whatever per kilowatt hour expensive diesel fuel to provide that electricity. So that it's not turning out to be super cost effective for them in Tok. They're, again, I want to stress that it's really dependent on community details. How much does the electricity cost to you, the person charging the vehicle? How much would you pay for gas for the gas vehicle, and how much, where are you parking it? How long are you driving it every day? How harsh are your winters? Things like that. So there's a lot of variability. There are some ways that these things will undoubtedly get better with time. The more a community installs renewables, the more of that power is cleaner, and so that emissions benefit goes up for the electric vehicle. You can't clean up the emissions generally really from a gas vehicle, but the electric vehicle, the same electric vehicle as the electric grid, it gets cleaner, it gets cleaner. As far as cheaper, that depends on electricity prices, but there are some thoughts about trying to pair times where there is more renewables, which if you have more renewables at a certain point in time, like wind or solar, than you can use on the grid, can you make that a little cheaper to something like an electric vehicle that could soak it up right there, then and there? And so this plot at the bottom center is actually a plot from my house. I do have solar panels on my roof in Anchorage, and I do have an electric vehicle. So I'm charging at night because that's when it's convenient to me, and when Tok Electric would like me to charge because they don't have a lot of electricity use then. So it's beneficial to them. But there's this big pile of blue energy use up to 8 kilowatts to charge the vehicle at night. And then during the day, my solar panels are overproducing and sending power back to the grid. On the rail belt, we get net metering, and I get nearly full value for that. But if we didn't, and I was getting a reduced cost for that, or if this was utility provided renewables and they weren't having to buy diesel fuel for this generation, it might really make sense to try to use controls to match these two things up as much as possible, and to try to pass along emissions and cost benefits to electric vehicle charging. This stuff is all in the realm of research right now, trying to figure out communications, control structures, how that can all work out. It's not something you can just probably implement tomorrow in your in a small community, but we're trying to solve this as quickly as we can and figure out what makes sense.
Okay, Michelle, before you move on,
Yeah.
do you have any information in regards to airplanes?
So there are companies that have gone through like the Launch Alaska tech cohort that are really looking at electrified air transportation. I don't have any data on that. There aren't really commercially available projects right now. There are companies that are putting in orders, pre-orders for electric airplanes. I think that there are probably going to be some short haul applications there. Longer term gets challenging because those batteries are heavy. It's the same thing like for fishing fleets. For short boat trips with maybe a lot of idling, they're looking at electrification of boats. But for longer haul fishing trips where people are going really far, they're looking at hybrids right now. You know, you can't, a car you can charge if it's on the road system and there's a charging station along the way. But if you're in the air, out at sea, off on, you know, across the tundra on a snow machine, and there isn't charging, that range restriction of the heavier battery can get in the way. So some opportunities and some challenges in air travel. Hopefully that answered the question. Happy to talk more at the end if not. Not that it answered the question, but to the best of my ability. We are continuing the work we're not working as closely with Bethel anymore. We had a harder time making good partnerships within the community. But we have what we feel are great partnerships with folks in Galena and Kotzebue, and we are starting on a continuation of that research project. We're putting together, well, I'm not, but the UAA's automotive department and the Alaska Technical Center in Kotzebue and Galena Interior Learning Academy, which both of those are associated with the school districts and their communities in Galena. Anyway, are working on intro EV maintenance training, since that became that showed up as such a big barrier, not knowing, if you can even change tires safely, what not to touch an electric vehicle to stay safe, sort of some of those things. Galena, it's do it yourself if you want to fix your vehicle. And there's a lot of that going on in Kotzebue as well, even though there's some shops. So what can you do if you have an EV that needs maintenance in communities? So working on that barrier. We are hoping to buy some off-road electric vehicles for our partner communities, the city in Galena and the tribe in Kotzebue, to test out for us and collect data on, so that we can get a better handle on how those might work in certain use cases in rural Alaska. And just more of the research of how people use their vehicles, what they need from their vehicles, how these will interact with electric grids, what the opportunities are for making things better for people. So these are just slides about that. But we want to make sure that any energy transitions, or the energy transitions happening, there are many of them, many aspects of them. We want to make sure that we are not leaving rural Alaskans behind, and that things are beneficial, that people aren't ending up with bigger bills, more carbon emissions, or something that isn't working out for them. And so that folks are making really informed decisions as they look at adopting new technologies. So that's all I have, and I'm really happy to enter into discussion about any of these things.
All right. Well, people are welcome to either raise their hand or to post questions either in the question and answer box or the chat. I posted in the chat a link to the technical assistance and resources for tribal nations from the Joint Office of Energy and Transportation that relates to electric vehicles. There is additional resource out there for tribal groups, and that includes Alaska Native communities and tribal and councils, for funding opportunities to get electrified vehicles for public use. Admittedly, currently, the buses that are available for electric use are large, which probably doesn't apply for most of rural Alaska. But I was at a conference recently where they were talking about manufacturers are investigating smaller buses having electric options. But again, that, as much of Michelle was saying, there's a lot of research and a lot of work, but people are looking into these subjects. All right. Anyone? All right. Zochi, I'm allowing you to talk since you have your hand raised.
Okay, can you hear me?
You're very faint, so you might want to speak up a little bit.
Okay. I'm wondering about towing. So what happens if a car breaks down or something like that? Is there any like emergency support that you guys are thinking about for a car that may break down? Like, for example, if it's a car that runs out of gas, then somebody could bring them a gallon of gas. But now, how are they going to get rescued if they run out of electricity while they're operating the vehicle?
Yeah, that's a good question. I think the most common thing that happens is being towed to a place that the vehicle can charge. I know that's even my mom's taken that option in California with her electric vehicle, even though I've heard that some tow truck companies there have, I don't know if it's generator based or battery based, but they have the ability, some of them, to charge vehicles from the tow truck itself in the field for a broken down car. So yeah, it's a consideration. I know there's a Finland company. I don't think their snow machines are available here, but they show their snow machine being charged from a vehicle on their online picture, and they say you can share charge between snow machines or a vehicle to a snow machine. So maybe in the future, more vehicles will allow vehicle to vehicle charging, so that your friend with a full battery could come and give you enough juice to get home. But yeah, definitely something to think about. What happens if you do run out of power? Now, just like people with a gas vehicle try very hard and generally don't run out of gas very often, people with electric vehicles are pretty conscious of their range. It's something that shows up on the dash, and certainly a new adopter. When I first got mine, it was something I was looking at all the time, even though I mostly just drive around town. So it's a fear, but probably not a super common occurrence.
Yeah,
Right.
so I actually had a electric vehicle, a Leaf, and
Mhm.
one of the major problems that I experienced with it was whenever I would try and charge it at some place other than my home, a lot of the chargers were broken, and I'm wondering, how about the reliability of public charging facilities? Like, are you guys thinking about that at all?
Yeah, that's a big issue. I mean, luckily with the communities we're working in, they're small enough that you're not going to be very far from home. And, you can charge all of these vehicles with a charger that comes with the car that plugs into a standard outlet, like a block heater outlet or an outlet on the outside of a building, which, depending on how far you are from home, might take a little bit of time, but you're going to be able to limp home if you can do that. So, there's some scariness in that electric vehicle charging is not as ubiquitous as gas stations right now, and range on your EV can be a little lower, and not for all EVs. Some have longer range than gas vehicles. And charging times are slower than refilling with gas, but there is also a whole lot of opportunity in the fact that anywhere there is a plug-in, there is the opportunity to fill up at some rate. And just like with plugging your iPhone in at night and going to bed and waking up the next day and it gets you through the day or maybe more, we plug our vehicle in at night, some nights, like once every 2 weeks, and then we have enough charge to do our commute around Anchorage for the next week or two, depending on the season, less time in winter and more time in summer. So I'm never looking for a charging station unless I'm taking a road trip. So, yeah, absolutely. I mean, it's a new way of planning how you take care of your vehicle fueling, and I understand not everybody wanting to make that change. And the problem you stated is real, in that if you are depending on a charging station because you are taking a road trip, right now there are not a lot of competitors. We went down to Seward and there is one fast charger in Seward, and if that had been down, we would have been staying a few more extra hours to plug into the slow charger to get enough to come back. And so, there's not as many pumps available, outlets available for the fast charging in the state as would make most of us really comfortable with that, relying on it for longer distance driving. And my mom has had the same problem with her Leaf in California. It's a different charging system than Teslas and most of the other cars, and so they are even less maintained than some other chargers. So it's something that's comes up in my email feed all the time as something that people are working on. And the government money, the federal funding for charging stations has an uptime requirement, but if it's not met, I'm not sure what the penalties are, but you get your grant money if you promise a large amount of uptime, 90-some%.
Okay, there's some questions that have come up in the chat. Specifically, what happens if a battery gives out? Are batteries replaced in electric vehicles?
Yeah, they are. It's expensive, so you don't really want to do it. Any new electric vehicle is going to be under warranty. So, if it was an accident, that's one thing, but if it was a defect, then that shouldn't be on you. But here's a big problem with rural Alaska: is if it takes $5,000 or more to put it on the barge to get it back to Anchorage where the dealership is, and they can replace your battery under warranty, that's still a $10,000 replacement if they're not going to cover that, which a lot of people don't. This is a problem for non-electric cars too. I talked to somebody who bought a brand new Subaru and it had some warranty work that really needed to be done, and they had to, out of their own pocket, ship it back to Anchorage and back to get the work done. Some people find a way to get that warranty work done. I've heard of people with fleet vehicles that were able to somehow negotiate to get the little part they needed and do the work themselves instead of shipping it to the dealership. But that can become a problem. My Bolt had a recall on the battery because there were some defective batteries, and they just decided they didn't want to take the risk of bad battery in vehicles, so they recalled every single one of them. And the dealership here, replaced it for free, and it was really easy. But I live in Anchorage, so that's definitely a thing, is that replacement is expensive if you have to pay for it yourself, or if you have to pay to get your vehicle to a dealership. Definitely something to think about.
Is that something that can be fixed by hand? So, I mean, is there an aspect of it as part of the education for people to learn how to fix that?
That's a good question. We have an automotive team here with some certifications at EV training. So they would probably, if people want to email me, and this is my email here, mmwilber@alaska.edu, I can pass you along to Darren with UAA Automotive. These are pictures the dealership sent me of replacing my Bolt battery. So they unplugged a couple things, they put it up on a lift, they unplugged a few things, they undid some bolts, and they took this battery pack down, and then they lifted the new one up and did the bolts to hold it in place and plugged the things back in, and it was ready to go. But you are dealing with things that can give you a really nasty shock if you do it wrong. So you need correct certification and tools, and your workspace needs to have certain requirements for high voltage electric safety. And so I don't think replacing the battery is intended to be a do-it-yourself thing at the present moment.
All right, the next question is, does freewheeling charge a battery when it's moving?
Freewheeling.
Related, I think, to the, because it's in, and there's another statement that says the Rivian, for example, is designed to be charged while being towed.
Yeah, so regenerative braking. So anytime the wheels are turning in the wrong direction, they can turn the motor and a generator are the same thing running in different directions. So all EVs have regenerative braking, which means that instead of using up your brake pads, you can use the resistance of turning the motor in reverse and charging the battery instead of discharging the battery. And that can add, there's always losses. There's always thermodynamic losses in every process. So you're not going to get back to where you were at the top of the hill, but you are, or at the bottom of the hill before you went to the top of the hill. But you can recharge that battery by running those tires the opposite way, either by braking or by towing. But that's vehicle specific, and all the vehicles have different requirements about whether they need to be towed totally off the ground or whether you can put it in that mode. So if you have an EV and you need to be towed, read your owner's manual, do it right, don't hurt your vehicle.
All right, and then there's a question about how can we prevent electric vehicles dying out in the cold weather conditions?
So modern electric vehicles are working great. We have lots and lots of stories of people driving their all kinds of electric vehicles in Fairbanks at -40 with no problems. In fact, fewer problems than the gas vehicles, other than the energy use, range loss, potentially slower charging. So as far as things going bad, that generally has to do, pretty much all these hybrid and fully electric vehicles still have a 12-volt lead acid starter battery in them. And in some cases, I've heard this with some hybrid vehicles in Fairbanks, I think they probably didn't properly think about the thermal needs of that lead acid battery, and some people's vehicles were dying over a cold snap last winter, and it turned out to be related to that. People with older Leafs and some other vehicles have had to protect that 12-volt battery from cold weather or the extreme cold to keep it happy as well. Trickle chargers, battery blanket warmers while it's parked, things like that. But in general, I have not heard of a lot of problems for electric vehicles in the cold that are not related to keeping that 12-volt lead acid battery happy if the manufacturer has not thought really well about conditioning that. They've always thought really well about trying to keep the lithium ion big battery happy, but sometimes there's a little less attention paid to that. I think this is based on anecdotal evidence and conversations, not my absolute expertise. So talk to others about it as well. Don't always just take my word for that. But these are things you have to pay attention to with gas vehicles as well, and as far as battery blankets and block heating and things in extreme cold. So yeah, they might need a little extra care in certain cases.
All right, there's a follow-up question. So that's asking, so we can charge the battery while getting towed, but it has to be in reverse.
Well, there's a mode. Read the owner's manual. All vehicles are different. Some of them you're not supposed to charge the battery while getting towed. Some of them you have to put it up on the, you not have any wheels hitting the ground while being towed. It depends on the vehicle.
All right, and I had a thank you from someone as well for your information, Michelle, and who has students who are interested in the topic as well. All right,
Awesome.
so any other questions for Michelle, either by raising your hand or posting?
And absolutely, I encourage anybody with interests or with students who are interested in staying abreast of the project or other questions you think of later, please reach out to me. I am not the expert in all of these things, but I'm happy to try to track down the people that are, and we will, undoubtedly be developing products that would be great for classrooms and things like that as this research goes on. It's a big team of people, not just me. So we're happy to help out with your needs around this, around the topic. So thanks for paying attention.
All right, well, thank you, Michelle, and I'm going to stop recording. And one last question. There's a statement about in the next couple of years, EVs will have improvements and not that they're constantly improving. Is that correct, Michelle?
Yeah, absolutely. I mean, all things, even gas cars. I was watching How It's Made yesterday about how they've made the body parts so much lighter weight and stronger by water casting or whatever the pieces. It's like all of technology. People are figuring out new ways to make it better, lighter, more efficient, and that's true of EVs as well as other technologies. So hopefully continual improvements.
All right, well, Michelle, did you ever learn what Taiga is doing for battery management? They claimed that their snow machine started and operated without problems at 40 below in northern Canada.
Hi, Tim. Yes, I don't know the answer to that question. However, pretty much all vehicle, the Ford F-150 Lightning, Chevy Bolts, Teslas, they're all starting and operating at -40. And it's because they have a thermal management system that keeps the battery warm. Well, I mean, batteries have cold limits. They have sluggish behavior. The electrons don't flow as easily at colder temperatures. And if you get them cold enough, the liquid electrolyte in many types of batteries, including those commonly in cars, can freeze, and that further inhibits their functioning. But the cars and the snow machines make sure that doesn't happen by keeping them warm. So they have a system to make heat and pump that heat through the battery to keep it warm enough for its function. Hopefully that answered the question enough.
Of why they die in the cold?
Yeah, and the specifics, Tim, on the Taiga, nobody will ever share their thermal management details. That's why I collect data. I can kind of see how many watts the heater's using by what the energy ramps up to as you're charging it and it's plugged in and heating the battery or heating the cabin. I can kind of see the cycling it does and how much energy it uses over time, but none of those manufacturers will share those details.
Lovely proprietary data.
Yeah, sometimes the owners forum, somebody who's worked on them or is familiar will post about whether it's liquid or air, heated and cooled, and some of the things. So specific vehicles, you can look into it and check it out. Keep my battery in the house, keep it warm. Will it last me the whole day? Well, last you the whole day. It depends on the use. But I love that idea for smaller batteries. Cars have really big batteries generally, but I think I'm really interested in getting a group of students together somewhere, maybe in a school in rural Alaska, maybe a UA student group, and seeing if we can build onto an old frame an electric ATV with removable batteries so that you can take them into an Arctic entryway or inside the house and keep them warm and then bring them out. I think that would be a great innovation for, people do that with their electric bicycle batteries. Those are small enough to bring inside and keep warm. So if we could do that with other smaller vehicle batteries like ATVs, those also tend to be big and heavy, but maybe they could be modular, and that would take a lot of the energy use off of them. If you leave them out and they're in a vehicle like a Polaris or somebody who's planned for the cold, it will keep itself warm. It will just take extra energy.
All right. Any more? I mean, this is great. I threatened to turn things off and more people pop up with questions, but it is almost 2 o'clock. So we're coming to the end of our primary time interval, but you're welcome, John. Thank you for joining us. We appreciate your interest in this topic. If there are other topics people are interested in, please feel free to let me know at the Alaska TTAP, and I will work to get webinars set up on those topics. This particular webinar came out of someone contacting me and asking for something on electric vehicles in Alaska. So on that note, thank you again, Michelle, and I'm going to stop recording and turn things off.
Thanks, Victoria.